Alrighty, let's talk electron configuration. This is kind of an extension of the quantum model of the atom, and now we have some understanding of that quantum model with orbitals and sublevels and things like that. And now we can look into something called electron configuration, which helps us to understand where the electrons are located within the atom. Okay, and so here's the thing to remember, is that electrons will fill the lowest energy level orbital possible. And so here's what we know after the last video. This is just portion of a Bohr model here, and this is the first energy level, second, third, fourth, fifth, sixth, and seventh energy level. And we know that these energy levels hold a maximum amount of electrons, which are listed by these numbers here. Just as a review, the first energy level is only comprised of an S sublevel, okay? And when you think S, think 2, okay? The second energy level is comprised of S and P sublevels. When you see P, think 6. The third energy level is S, P, and D sublevels, okay? And so when you think D, please think 10. So we have 2 plus 6 plus 10, that's what gives us 18. The fourth and the fifth energy levels are both comprised of S, P, D, and F sublevels, okay? So that's 2 plus 6 plus 10 plus 14, and that gives us our 32, okay? And that's true for both the fourth and the fifth energy level. The sixth energy level contains only an S, P, and D sublevels, and so that's our 2 plus 6 plus 10 for 18. And then the seventh, we know for sure there's an S sublevel. We're not sure beyond that. There could be, okay? So there's definitely an S, and there may be P sublevels as well. So it's 2 and maybe as much as 8, okay? But they don't just fill in from the lowest energy level out. That is part of it. We want to fill the lower energy levels first and then move outward, but there's a couple little tricky points to this. And that's because these different sublevels and different orbitals, they have different energies. And the rule is that the electrons will occupy the lowest energy level orbital possible. And so there's some funny things that happen here. And it turns out that in particular, an S orbital is lower in energy than a D orbital. Okay, S is lower in energy than D. And so that's where the funny thing comes in, and that's what we're gonna try to understand here. So here is something called the diagonal rule. And what I've done here is just taken the energy level and divided it into what sublevels are present. That's pretty much what we just did here. So we're gonna make ourselves a little chart here, which is gonna be incredibly useful to you as you move on. Okay, and so what I've done here is just set up a chance for us to look at what energy level holds which sublevels. And this is just coming right off of this sheet here. So in the first energy level, we have S, second level, we have S and P, third level, S, P, and D, and so on. So I'm gonna label these as 1S, and that's all there is in the first energy level. In the second, we have 2S, and we also have 2P. In the third energy level, we have a 3S, 3P, and 3D, remember? For a total of 18. In the next two, we have S, P, D, and F sublevels. So 4S, 4P, 4D, and 4F. Okay, in the fifth, same sublevels, 5S, 5P, 5D, and 5F, okay? In the sixth energy level, we only have S, P, and D. 6S, 6P, and 6D. And in the seventh, we for sure have an S, and we'll put a P sublevel in there too, just to be fun. Okay, so we have 7S and 7P. Okay, now what this chart is going to allow you to do is understand the order of energy level and sublevel that fills as electrons are built into an atom, okay? So we want to start with our very first sublevel, which is 1s. From 1s, the next thing that fills is 2s, okay? From 2s, we come up here and fill the 2p orbitals, okay? From 2p to 3s. So everything is going good here. We're just filling in electrons in the first energy level, second energy level, and third energy level, okay? From 3s, we come up here to 3p, okay? And this is where things are going to start changing. We do make the move into the fourth energy level, and we begin to fill our s orbitals in the fourth energy level, right? But you'll notice here that according to our chart, all we've put into the third energy level so far is 2s orbitals and 3p orbitals. And that means that we only have put 8 of the total 18 into the third level, and we're moving on to the fourth level before the third is full with 18. And so that's the goofiness here. We actually backfill some electrons before, after we move on to an outer energy level. 4s to 3d. Now, after we fill the first electrons into the fourth energy level, the next 10 electrons will go back into the previous level, the third. After that, we then are full in the third level, and we begin to then fill up the fourth level. But before we finish filling the fourth, we move on to the fifth level. And the fifth level, this is where it gets really goofy, moves back to the fourth level. And so we start to fill one level, and then we backfill into the previous level to completely fill that up. 4d to 5p, 5p to 6s. We're now in the sixth energy level before we've completely filled up our fourth level, right? Which is funny. But the next thing we do is backfill into the fourth energy level with 14 more electrons, which then gives us our total of 32. The next place is then back into the fifth energy level, back up to the sixth energy level, and now the fifth level is completely full, the sixth level is partially full, and then we start to fill the seventh energy level. And the seventh then gets partially filled, and then we backfill into the fifth, backfill into the sixth, and then finally we finish out the atom with 7p. And so what you can see here is that the electrons fill into the lower energy level orbitals before they fill a complete energy level. Okay, and so let's put this into practice here, and let's build up a Bohr model of let's say iodine atom. So here's an iodine atom. So we know that an iodine atom has 53 electrons in its atomic form. And so we've got to put 53 electrons into these 5 energy levels. And I know that there's 5 energy levels because iodine is in the 5th row of the periodic table. Its position is right here, okay? That symbol could read iodine, okay? So, and this is the 5th energy level, okay? So we gotta fill 5 circles. So the first thing we want to do is think about how these are going to fill. And we know that the first 2 electrons will fill into the first energy level. The next energy level holds our s and p orbitals, and that's a total of 8 electrons. So there they are. Okay, and so what we've done here is we've started at 1s, we filled the 2s and the 2p orbitals. Now it's time to move into the third energy level and fill 2 electrons into the third. So we can put 2 electrons into the third energy level. But then we're going to fill from 3s to 3p, which is another 6 electrons for a total of 8 in the third level. Okay, and this is where it gets kind of weird, because that third level holds a maximum of 18, but we're gonna start to fill up the fourth energy level before we completely fill the third. So the next electrons that go in here actually go into the fourth level. So that's our 4s electrons, of which there are 2. And from 4s, then we can backfill into 3d with another 10 electrons. So we got to come back here to the third and fill 10 more electrons. There's 2, 4, 6, 8, and 10. Okay, so now we have a third, full third sublevel, a full third energy level, excuse me. Now, after 4s, we move to 3d, that's what we just did. Now we continue filling up the p, the fourth energy level with our p electrons, of which there are 6, 2, 4, 6, okay? So we filled those 4p. Now we're gonna start to fill in the fifth energy level with s electrons, okay? So our fifth energy level, we're gonna start to fill it before the fourth energy level is completely filled. And now from 5s, we come up here to 4d. And 4d, now we've got to put 10 more electrons into the fourth energy level. 2, 4, 6, 8, 10, okay? So that fourth level is not completely full, but it is as full as it's going to get for iodine, right? And after those 4d electrons, we move into 5p. Now, 5p, we're not going to completely fill those 3 orbitals. And that's because in our periodic table, you can see, where did I put that? Here it is. That iodine lives at this 5th position within the p level. So we're only going to fill 5 of those 5p electrons. And so we're going to add an additional 5 electrons into the 5th sublevel, and that into the 5th energy level, excuse me. So that is 2, 4, and 5, okay? And that accounts for all 53 electrons in iodine's atom. All right, and so through the magic of chemistry, you can see that the outermost level can never contain more than 8 electrons. And that's because the s and the p sublevels fill, and then the d electrons from the d orbitals will backfill into the previous energy level. So that means that you can't have more than 8 electrons in your valence level. Okay, so let's do some electron configurations here, and let's look at the one for iodine, since we just built the Bohr model. And so we're going to use this sequence to write out what's called an electron configuration. Okay, and our electron configuration ends with this notation right here. So 5p5 is going to be the very end of our electron configuration. Okay, but let's go through and build it all the way up and describe the electrons in each energy level. So we're going to follow 1s, and then because there are 2 electrons in that orbital, we put 2. 2s, 2. That means that the s orbital is full with 2 electrons. 2p6, right? That's our next stop on the diagonal rule here. And that just means that each of these 3 p orbitals has 2 electrons for a total of 6. After 2p6 comes 3s2, then 3p6, 4s1. This is that goofy place where we go from 4s and start backfilling into the 3d. Okay, 3d10. From 3d, we go back into 4p. 4p, and there are 6 electrons in that sublevel. From 4p, we go to 5s. And from 5s, we go to 4D. And there are 10 electrons there. And after 4D, we're at 5P. And that's kind of the stopping point because that's where iodine lives, on the 5th energy level in the P sublevel. And that is the electron configuration. Okay? 1s2, 2s2, 2p6, and so on. And when you add all these superscripted numbers up here, you're going to get the number 53. So the electron configuration shows you what energy levels and what orbitals and what sublevels are full of electrons from the very innermost energy level to the outermost level. Okay, so that's how diagonal rule works. And I particularly like this periodic table because it shows you, especially moving here from the 4th energy level, you can see that you read this like a book. Here's 4s1 and 4s2, and then it goes directly into 3D. So you can see that the D block of elements actually drops an energy level, which is a little strange. And then at the end of the D block, we bump up to 4. Here's 5 to 4 to 5, 6 to 5 to 6, and so on. Now these F orbitals, they fit in right here. That's why after 6s, we move to 4f. It drops 2 levels. Okay, so this goes from 6s to 4f to 5d to 6p. So it takes some practice, but you'll get it. It's just one of those things you gotta practice at quite a bit. Okay, hope that helps.